I'm going to try to tell you everything you need to know about the subgroup tests in abstract algebra in under 3 minutes. Let G be a group. Just a reminder, what does that mean? Well, it satisfies 4 axioms. 1, you can put elements together. 2, that operation's associative. 3, there's an identity. And 4, you can always undo the operation. Here's an abstract picture of G. Now let's take H to be a subset of G. Is there a fast way to check if H is a group? In other words, if it's a subgroup of G, without having to go through all 4 of these group axioms? We know G is a group, so the operation is associative on all the elements of G. But all the elements of H are also elements of G. So the operation is associative on all the elements of H as well. With that in mind, it suffices to check 3 of the 4 group axioms to see if H is a subgroup of G. Those are 1, the identity is in H, 2, that H is closed under the operation, and 3, that H is closed under inverses as well. I'll quickly sketch out what these mean. 1, the identity lives in H. 2, if X and Y each live in H, their product can't live outside, it must live inside H. And 3, if X is in H, its inverse can't live outside H, it must live inside H. Let's use this test to show that the 2x2 diagonal matrices are a subgroup of the 2x2 invertible matrices, called the general linear group. First, notice that the identity matrix is certainly diagonal. Now take 2 diagonal matrices A and B. Well, their product is also a diagonal matrix. Finally, if you have a diagonal matrix, then its inverse is also a diagonal matrix. Thus, we've satisfied those 3 axioms from the test. So we've got a subgroup. There's an alternative, slightly faster way to check if a subset H is really a subgroup of G. I'll call it the subgroup test 2. And what it boils down to is checking that H is not empty, and 2, if X and Y are 2 elements of H, then X times Y inverse is an element of H. We'll use this alternative test to show that if we fix an element of a group and look at all of its quote-unquote powers, that forms a subgroup. First, we need to demonstrate that H is not empty. Well, notice the identity is A to the 0, so the identity is in H. Second, let's let X and Y be 2 elements. Well, that means that they are both powers of A, and now I can just use exponent rules to convince myself that X times Y inverse is also a power of A. And that's it. H is a subgroup. Good luck using these tests in your class.